Hey everyone, Rob here from Rising Edge Industries, and I just wanted to put up some content as this data recorder is coming out of development into testing phase, and put some content up so users can get familiar with some of the tools and the performance and prove out some of the data integrity of the architecture and memory bus and the recording engine. And so this is just going to be a quick 4-channel example. Just overview, this device has got its own battery pack. It's going to come completely 100% plug and play, no drivers required from the factory out of the box. The only thing you'll need is this GUI to configure and download the data. And so we'll run through this real quick. The first thing you want to do is open up the USB connection. You see your battery voltage reported back here in real time. You got a memory address, and so that tells the recorder how far into the memory structure to write data, and when you download data it tells it how far in the memory structure to read data from. And so get config gets our current configuration. You can see we can set that to something else, go from 4-channel to 2-channel mode, from 125K to 10 Hertz. And so for this example we use a 4-channel mode. Maximum speed in 4 channels is 125K samples per second. We'll read to memory address 65,535, and so that'll be 65,535 samples. Keep in mind that the samples are actually 2 bytes, they're 12 bits, and so for the embedded architecture that's going to be a 16-bit word. And so all of this configuration is from the point of view of samples, which is actually going to be 2 bytes. Each sample is going to be 2 bytes, so it really multiplies by 2. So that's actually going to be 128K bytes, or 65K samples. And so in 4-channel mode, we're going to have one sample, one 12-bit sample or a 16-bit word per channel. So that's going to divide down by 4. And so we'll see that when we run the run this demonstration. And just a note, there's well, I'll talk about that in a second. There's sector erase, and so this is just good to develop this for bench testing, because the memory array is a gigabit, and it takes a while to erase a gigabit memory space, just because it's just so much memory. And so this allows you to erase by sector, and so what I just did there was to erase up to sector 2, which is going to be 512K words, or 1 meg samples, or 1 megabyte. And so it's much faster. And so now the device is ready to go. Reset. That resets the recorder, and it resets this application. One of the big things in the application does is actually clears out your data file. So in bench testing, when you're doing a lot of iterations, you've got a quick erase, reset the recorder and reset the application, and you're ready to knock out a whole bunch of iterations in a short period of time, which is really convenient when testing sensors and just checking out the device in general and stuff like that. And so now the device is ready to go. You can see our configuration's good, memory's erased up to where we want to be. We're set to run to 65K samples, and we've reset the device, cleared out our data file. So we'll hit start, and then it's done. We'll download. A couple things to note while it's downloading the data is that the device right now for this demonstration actually has a development firmware code set, and so instead of recording 4 different channels tied to the input pins, we're actually recording a 16-bit counter inside the device. And so this is, like I said in the beginning, is to prove out the robustness of the memory bus and the architecture, the accuracy of the device, and prove out that we don't lose any samples, which we'll use another tool real quick to prove that here in this video. And so now that the recording's done, go check out the data file, and let's see, open up the data file on screen. You can see this free running counter over here, and each channel is going to store one of these counts. You got 0, 0, 0, 1, 1, 1, and it's going to run and run and run and run until it reaches that memory address and then stops. And so we scroll down to the bottom of the data file. We'll check out the end real quick. And so if we do a quick calculation on this. We've got 536 samples. Divide that by 4, and so that's what we should get. And because we actually pull an extra 2 packets out over the USB link, because this device always records 1 block over what the user specifies to make sure that there's no data loss during the mission or the timeline for testing. And for downloading, it does the same thing. It pulls out an extra 2 packets from the memory space over what you set, and so we'll add those bytes in here. Let's see, 62, and so since it pulls out an extra 128 bytes, or 124 bytes, and now we line up 62,507, 62,507. This is going to be a little bit behind just because it's starting from 0, and the counter is, and we're storing the 4 zeros. So it matches up, and if you check out, let's see, in the IDE, you can see actually the line numbers. You can see 16,508, 2 samples into that, matches up with the expected calculated value here. And so that worked out fine. Now we've got to make sure that there's no missed samples, like it doesn't skip from 199 to 201 or 203. Make sure that every single iteration counter is pushed across the memory space successfully and then read back out. So it looks like it is, but I also wrote a tool to go check this. We'll run this real quick, and we'll be done with this demonstration. So this tool is, what it's going to do is run through the data file and then give us a plot. So we'll check out the plot first. And so we've got a little GUI here. We'll launch the 4-channel mode, run the launcher, and first thing we're going to do is move our data file over from here to our parser, paste in our data file, run the launcher. Run the launcher. Let's see, copy, paste, okay. Okay, alright, now we've got our launcher GUI, picked the number of channels, 4 channels we just recorded, 125K, run that, and so this does a couple things. It's going to print or show us a little graphical display of each channel, 0, 1, 2, 3. And so that's going to match up with this data file over here. As you can see, 4 channels, 4 columns, 4 graphs, and it runs to 16,500 roughly. So if we look at this, we're at about 16,000. If we look at the very end of this section, you can see we're at about 16,500, a little bit over, but not too much. Zoom in on that a little bit, and you can see it approaches 16,500. And so that's what all the samples look like. To check the data integrity, close that, and check out the thread that we launch. And so to prove that there's no problems, the source code will be up on the website as soon as I get a chance, and some of this development code is a little more refined, but these development tools I probably won't release for a little while. But what this does is it checks every single data point to a comparison, which is just another free running counter. It starts at 0, and it's going to increment until it reaches 65,535 and then restart. So as you run this deeper and deeper into the memory, you'll see this memory in the firmware and in here both roll over and sync, and if there's an error, you'll see where the error is. And so what we'll do real quick is induce an error in this data file and then run the same tool and see what happens. So we can prove out that if there is an error, we can find it. So we'll go down to somewhere in the data file and change this to 420 So that sample is actually going to be one count ahead. It's supposed to be 419, 419, 419, channel A3. We'll say that got the wrong sample. We'll relaunch this application and bring it over here, run 4-channel mode, run that, and move up. And so you can see actually we threw an error here in the data file. Row mismatch on 4620, and so we'll go to 4620. The data value, channel 3, is going to be 4620, and so we'll jump in here. 4620, 0, 1, 2, 3. There's our error. Change that back to 19. Save the data file out, relaunch the application, and we'll get our plots back, and it shouldn't error out and give us any problems. Yep, here they are. So no errors, no problems. Channel lengths for data files are all 16,507, and that's because to plot all these in unison, it's going to leave out. It's actually going to leave out the two that result in the channel mismatch, so that when you plot with the x-axis, they all line up lengthwise. So leave these two out, but it's not a big deal. The length is 0 to 16,506 or 16,507 samples long. And so that's it. Hope this video wasn't too long. I'll try to put up some more content. If you're interested in getting into the beta testing cycle, contact me through the website, and there are more videos to come.